I can tell you how happy I am to be here because I've done a couple of conferences last year and I've done quite a couple this year, but I've never had the opportunity to speak at TechDays. And TechDays was also my first conference that I ever attended. It was the first conference that made me realize that we're not just building some ERP products, but that there's more, there's the whole community behind it. So, I'm happy to be here. And to all of you, welcome to Reviewing the Code Review. I always like to start my presentations by explaining a little bit where did the idea come from? Why do I love talking about code review so much? And to understand why I like code review, we have to take a quick tour through my career so far. So far, I've worked for 3 different organizations. I've worked for a really small VAR partner. It was like a garage firm where we developed directly in production databases, right? It was the CAL times, and honestly, who in CAL times did code review? Yeah, exactly. I'm proud of all of you who did it, but we didn't. Nobody did code review in those times. But then, at some point, I switched to a different company. I switched to the biggest ISV in Slovenia at that time. And in the beginning, we were doing code review. My code was being reviewed. And I thought, whoa, this is cool. But in about 6 months, code review just became another green check mark on a pull request. And then I switched again to my current organization, where I think we actually have quite good code review practices. We still have room to improve, right? But I think we're doing a good job. And when I was looking through my own experiences, 3 different organizations with 3 completely different approaches to code review, I was thinking to myself, well, you know, what about all the other partners? I think we have all adopted various practices in the 5 years since we got code review. And I think right now, it's a good moment to just stop and take a look at what are good practices, what are bad practices, how can we be better at code review. Now, before I go any further, I'll just take a quick minute to introduce myself. My name is Tine Starič, and I'm originally from Slovenia, though for the past couple of years, I've been flying under the Lithuanian flag because I went on a little career adventure of sorts. I work at Companion, where I work as an architect, which just means I don't only deal with AL code day in, day out. I also think a lot about the quality of solutions we create. I think a lot about the quality of products we develop with our partners or for our partners. And code review is like a tool that I can use to oversee what our development teams are doing, what kind of quality code we're producing. I've also just recently became an MVP. It was actually exactly 44 days ago, 7 hours and 26 minutes. I timed it since I got the email. It's a really cool time for me right now. I love being part of this group of individuals that love the product, are enthusiastic about the product, and love to share the knowledge with all of you. So, yeah, really a fun period for me right now. But back to our topic. What are we going to talk about today? We're going to go through 5 points. First, why do we do the code review? I think all of us, we have our own interpretation of why do we like code review, why it is important, but this is just for us to kind of establish a baseline that we all see, oh, these are the points why we should do the code review. And then we're going to jump into the process. How can we make the review process better, less boring, less annoying? How can we speed it up? And we're going to talk about the roles. So how can I be better when I review code? And on the other side of things, how can I be better when my code is being reviewed? And then finally, I also needed to include our co-pilot's going to help, because anything Microsoft touches adds a co-pilot somewhere. And honestly, I hope you didn't come to this presentation for that bullet point, because long story short, it's kind of boring right now. But still, I just want to show you what is there and how co-pilots should help with code review. But let's get to it. First question, why do we do the code review? Now, I could talk about we do the code review to ensure code quality. We do the code review because we want to follow coding guidelines. We do the code review because we want to find bugs and edge cases. But I found a quote on Reddit a couple of months ago that summarizes it much better than these bullet points. What the quote said is, ask yourself, if I had to support this in production tomorrow with no previous knowledge of it, how tempted would I be to send a glitter bomb to the developer who wrote it? When you think like that, it really cleans up a lot of your code. Right, so why do we do the code review? Because we don't want to find glitter bomb-worthy moments in production. With code review, we can catch all of these glitter bomb moments before code ever reaches the main branch. On top of trying to prevent glitter bomb moments, another reason that's close to me, why I like code review, is because it helps us avoid the lottery factor of one. Now, you might have heard it under a different expression. We usually say the bus factor of one, which, for those of you who don't know, means how many people have to get hit by a bus before we have a problem. But now, people getting hit by a bus, that's a bit morbid, so I found a different expression. How many developers need to win the lottery before we have a problem? And now, what I mean by this is, I think a lot of us, we have experienced situations where part of the code base, let's call it payments, are owned by just one developer. And then each additional feature, each additional change request, each additional bug ticket goes to that one developer, because that one developer architected it, that one developer developed everything, and it's the most efficient way how we can add a feature to payments. Yeah, it is the most efficient way, but you know, what's gonna happen if that developer wins the lottery? Or even if they just want to go on vacation for 3 or 4 weeks, who's gonna take the next urgent bug fix? Somebody's gonna have to, but they won't really enjoy it because they have no clue of the context, what was happening with payments. But if we do the code review, at least one additional person will see how the feature has been evolving. What kind of features have we added? What kind of bugs were we solving? And then at least one additional person will have a bit more context, and they will be able to work within this isolated part of the code base. So why do we want to do the code review? Well, because we want to avoid situations where we're completely dependent on just one person. An additional point, why do we want to do the code review, is knowledge transfer. Now, you could say that knowledge transfer kind of relates back to my previous point, right? We are transferring knowledge from the person who developed payments to the code reviewers. But in reality, what I meant by knowledge transfer is, let me put it this way. Who usually reviews code? It's the senior developers, right? Senior developers review everyone else's code. Now, this is something that I would like our organization to improve. We're not there yet, but I would like to include junior developers to be the reviewers as well. Now, not necessarily for the juniors to question or challenge, well, not to challenge senior developers' decisions. They can, if they think they found something, but more to just question, why have you done something, right? Why have you used a query object here when normally we just use find sets and gets and finds, and that works most of the time? Just for the junior people to be more exposed to different development practices, to best practices, to different development paradigms. So this is, let's say, a quite important point for me personally. Why to do the code review? Well, because we can share the knowledge from more experienced people to everyone else. So, if we just summarize, why do we want to do the code review? We don't like glitter bombs. We want to avoid situations where only one person knows the code base, and we would like to share the knowledge across all experience levels. Now let's move on into, let's not move on to the process yet. I have a disclaimer I want to share with you. I normally don't include memes into my presentations. But for this one, when I was preparing a couple of months ago, every time that I found something interesting, I said, I'm going to put that in. And this is the first one. There's a couple more to follow. But why do we do the code review? Because we would like to avoid a situation like this, where the same person opens the ticket, defines the ticket, implements the code, reviews the code, merges the code, and closes the ticket. Yeah, no. With code review, we split those tasks a little bit apart. OK, and now we come to reviewing the process. In this part, we're going to talk about how can we make code review better, more efficient, take less time. Now, I do kind of expect that we all know what Git is, and that we all know that pull requests are the place where we do the code review. So we're going to take it the steps further from there. And first, what we're going to talk about are policies. Now, with policies, it's the perfect way how we can ensure that every code change that would reach our main branch first has to go through code review. And I have a couple of policies set up in my examples today. I know a lot of you already know policies. I know a lot of you are already using policies. So we can just use this opportunity to talk a little bit, well, why do we set this or that policy up? Most of my examples are going to be on Azure DevOps. That's just because, well, our organization uses Azure DevOps. But in reality, every point that we're going to be making today, it's fully applicable to GitHub, to GitLab, to just about any source control tool you're using. But let's go to our policies now. With policies, we set them up on branches that we would like to protect from those changes. Usually that's main, but it could be just about any branch. And we go to options and branch policies. And let's talk a little bit about what kind of policies I usually set up. The first one being require a minimum number of reviewers. I personally would like for each pull request to go through at least 2 code reviewers, but I also do realize that sometimes the projects are just not big enough. So 1 reviewer is OK, but at least 1 person needs to review code. I don't like the idea that requesters would approve their own changes. I don't think anyone should have the power to directly merge code into the main branch. Even with smaller projects, for example, let's say my brother, he has a separate BC practice, and he works for 1 end customer. He's the sole developer, the only person there. And still, he opens pull requests and he tags me. I don't have context of that project. I will never find a bug there. But even then, I can still give him comments like, I think this could be more readable. I think you could structure this better. There's a new language feature in AL13 that I think you could use here. So I really don't believe that we don't need code review. There's always a need for a code review. I also always set up that when new changes are pushed, we reset all code reviewer votes, because even if I have already accepted a pull request and a developer decides, I'm just going to push 1 small change up, I want my vote to be reset, and I want to see what kind of change they have made. So whenever a new change is pushed, my vote gets reset, I get a new email, and I can take a look at the new changes. Check for linked work items. Now, this is something we're going to talk a bit more later, but the point that I'll be making is we don't want to only review the syntax, we want to review the change. Does the code actually solve the problem it's trying to solve? And we can only be sure of that if we know what the problem was. And if we have a work item attached to the pull request, well, then I can go and take a look at, oh, this is the problem you were trying to solve? Yeah, it solves it, or it doesn't. Check for a comment resolution. Always, even if I leave comments that I don't want the developer to address, I just say, hey, this was good. I want the developer to see that comment before we merge the pull request in. With merge types, I'm not dogmatic about merge types. Use whatever merge types you would like to use. But we have agreed internally that we would like to use squash merge, Because with squash merge, you end up with just one commit at the top of Git history, which means you're going to have quite a linear Git history, and it's going to be easy to follow. Now, with all of the other merge types, you end up in situations where some changes come from here, some changes come from here, some changes come from here, and that's when it becomes really difficult to see what's happening in our Git history. But like I said, I'm not dogmatic about it. Use whatever merge type you would like to use. Build validation, this is where you set up your pipelines. We won't be talking too much about pipelines today because there were sessions on pipelines, and there are blog posts on pipelines, and there are books on pipelines, and I think all of that knowledge covers it to a degree that we don't have to dive any deeper today. But what I would like to show here is that whenever we do set up pipeline checks, we ensure that builds expire immediately when the main branch is updated. Because if I have 2 pull requests, both of them have already passed the pipeline check, and the first one gets merged in, I would like the pipeline check on the second pull request to expire, because maybe now these changes are not compatible with the changes on this pull request. So the builds should expire immediately when the main branch is updated. Status checks. I personally, I've never used status checks. Has anyone here used status checks? 1, and you're a bit too far. Otherwise, I would ask you, how do you use them? Now, I did Google this. I still wanted to share with you what are status checks. But I was hoping somebody closer would share their experience with status checks. Status checks are used when we have some external process that our pull request should depend on. Right? We know, for example, if we build pipelines, we want the pipelines to pass before a pull request can be merged. And if we have our pipelines in Azure DevOps, we set them up here. But if we would be using some external tool, like Jenkins, right, for our CI/CD, that would be an external process, and when that external process finishes, only then can we merge our pull request, and that's what status checks are. That an external service can say, hey, yes, this is okay, you can merge this pull request, or no, you cannot. Finally, we have the automatically included reviewers. So for every project that we have in Azure DevOps, we create this group called code reviewers. We add all the people that should review code into this group. We add it here, and then whenever there's a new pull request opened, these people get notified of, oh, there's something else that I should review. And that's as far as I want to go with policies. I can just briefly show you that once we have policies in place, we can see that I'm still on my main branch here. I added a workspace file. If I would like to commit this workspace file, I can still do that. But when I would try to push this update up, this is when I would get an error saying, pushes to this branch are not permitted. You must use a pull request to update this branch. But that's policies. So once we have policies in place, we can be sure that any code change that would try to reach our main branch has to go through code review first. Now, the next thing I want to talk about are pipelines. I said I won't go deep into pipelines, but I still want to mention why are pipelines so important for the code review. It's because they help us avoid questions like, does it build, right? As a code reviewer, I don't want to care about, does the application still compile after this pull request? Now, you could say, well, the least the developer could do is just check if it still compiles or not. And I agree, but I'll feel much more confident if there's a pipeline that simply compiles the app. And then I can be sure, yeah, it compiles or it doesn't compile. Same with tests. As a code reviewer, I don't care if all the tests pass, because the pipeline is going to check for if all the tests pass. The pipeline is going to execute all of our tests, and it's going to say, some of them failed. Address that first. Translations, same thing. I worked on a project where we had to do translations on a pull request basis. as a code reviewer, I didn't care if it was translated. We added a step in our pipelines that just checked, are the translations done? If they're not, fail. Fix that first. So why are pipelines so important? Because they help us as code reviewers to avoid questions that we shouldn't be thinking about when we're doing the code review. And on top of these, let's call them technical checks, we can also automate checks for if the coding guidelines are being followed. This is where linters come into play. I think you know, all of you know linters, but under a different name. You know them as code cops, app source cop, per tenant extension cop, UI cop. So those are the kind of cops that ensure that we follow the guidelines from Microsoft, that all of the page fields need to have a tooltip. All of the page actions need to have an image. So do I, as a code reviewer, care if an action has an image or not? I do not. There's a warning for that, and the pipeline will fail if that warning is shown. But you can take it even further. You have your own guidelines in your organizations that you can automate as well with custom linters, with custom code cops. So this next part, I want to try to inspire you that custom code cops are awesome. One of the projects that I was working on was for this German partner that had, I would say, a bit weird requirements in how they want us to write code. They wanted to have global variables prefixed with a G. They wanted to have exit statements capitalized. And now, I'm not here to argue with you, should we prefix global variables or should we not? The thing was, partner wanted to have them prefixed. And that meant that I, as a code reviewer, I had to go through all of the global variables and just leave a bunch of comments. Hey, you missed a G here. Hey, you missed a G here. Oh, you forgot an exit. Oh, you forgot another exit. That's when I found out that we can have custom code cops, and we can create our own warnings. And now we have a warning if a global variable doesn't have a prefix, and the pipeline will fail if we forgot that. So as a code reviewer, I no longer have to care about variables or exit statements. Now these examples are a bit specific to that one partner, so I also included a couple other examples that are a bit more applicable to all of us. One of it is a commit statement. Commits are powerful, and sometimes we need them. But the problem with commits is that 6 months later, when you come back to that commit, you won't really remember why is that commit there. So we decided that every commit should have a comment. But that would again mean that I, as a code reviewer, I have to find each commit and say, you didn't put a comment here, put a comment here. Not anymore. There's a warning for that. Same goes for this example. Really simple procedure. Create new customer. Initialize a record, assign a number, assign a name, and insert it. If I come to this code 6 months later, did the developer want to skip the insert trigger, or did they just forget to specify the parameter? I don't know. Probably they don't know either. And that's why we decided that all internal methods must be invoked with explicit parameters. So inserts, modifies, deletes, all of that now needs an explicit parameter, and we have a warning so I, as a code reviewer, don't have to check that. And I have one more example of a linting use case, which was super powerful. We added it a couple of months ago. And here, actually, I want to include all of you as well. Let me ask you. Let's say you have a pull request where somebody added 4 fields on the customer table. It's just that. What's the problem here? Does anyone, and Arthur, you cannot answer. But does anyone else know what could be the issue here? No. I hear it. Some of you already know. But let me show you what happens when you deploy such an extension. Let me just connect again. Fun fact, this morning, my CDX environments, the environments where I created these examples, they all got deleted. So we almost didn't have a a demo here. But, you know, I got another one running. OK. So we merged a simple extension to the customer table. QA said it's fine. But then the customers, they went to contacts, and they find a contact that they like. I'm going to find this contact. And they just want to create a customer out of this contact. OK, I select a template. And there's an error that the following fields must have the same type. What's the issue here? Yes, our pull request only had 4 additional fields to the customer table. What we don't know as code reviewers, that a month ago, somebody added a bunch of fields to the contact table on different IDs. And when you try to create a customer out of a contact, transfer fields is executed, which means all of the fields from the contact table on the same IDs are going to be jammed into the customer. If there's a conflict on any of the fields, you're going to have a runtime error. Right? So that means that as a code reviewer, every time I'm looking at a customer table, customer extension table, I have to keep in mind, oh, we should actually check the contact table as well. Now, let me ask you, do you know any other tables that are paired the same way customer and contact are? Yeah, there's for example, vendor and contact. There's sales header archive, sales line archive. So let's talk numbers. How many tables in the base app do you think are paired the way customer and contact are paired together? Any numbers? What would be a 100? No. Well, the last time we went through it, 192. There's 192 tables that are in the base app coupled with transfer fields. Now, just imagine if I, as a code reviewer, I have to keep the context of 192 table pairs in my head whenever I'm looking at a table extension. Impossible. I have no clue how we have done this so far. But what we created internally is a rule that is going to go through all of these 192 table pairs. And if it finds that there's a field on the customer table and a field on the contact table that would clash, we throw a warning that the ID, name, and the type need to be exactly the same. Otherwise, we just end up with a runtime error. And now, I would like to show you where all of you can get the benefits of that. So I'm going to switch to a GitHub project over here. We know the app source cops from Microsoft, code cops from Microsoft. App source, Pertinent extension cop, all of the cops. This is the, let's call it the 5th cop that all of you can really easily enable. It's businesscentral.lintercop, owned by Stefan, and Arthur was a heavy contributor to this project. When I found this project about, let's say, what, two years ago, it had something like eight rules. One of them we already saw today. Commit needs a comment to justify its existence. Once Arthur got on board, this became big. We now have close to 60 different warnings that can be triggered. And the one that I was just explaining to you, tables coupled with transfer fields must have a matching fields. Right? You can read on the info page here how do you set it up? How do you set it up in Visual Studio Code? How do you set it up in your pipelines? And you don't have to use all of the 57 rules. Just enable the ones that do help you write more maintainable code that will help you be better code reviewers. So really, this is a great project. But if you enable lintercop, you like all of the additional rules, but you still have your own coding guidelines in your organizations that you would like to, let's say, automate, then I would invite you to check out a webinar I did with Luke a couple of weeks ago on Areopa webinars. If you don't know Areopa webinars, awesome YouTube channel, because you can find all sorts of topics here, from AI to interfaces to I don't know, all sorts of different topics. But the one I was aiming at is this one, Automating Code Quality, a guide to using custom code analysis. This is where I went a bit deeper into how do you create your own warnings and your own rules. So feel free to check that out. Okay, so that's what I wanted to share about custom linting and linters. In the end, once we have our policies in place, no code changes can reach the main branch. Once we have pipelines in place and linters, we don't have to worry about questions like, does it build? Do all the tests pass? Are translations done? Is it following coding guidelines? Not the question for the code reviewer. Let the pipeline answer that, and we can focus on the actual changes. Now let's talk a little bit about the softer side of the review process. I think you can already tell from the slides that I want us to keep pull requests small. Like, really, I don't have a problem with reviewing 5 small pull requests. I have a problem with reviewing 1 big pull request. I've never rejected a pull request because it was too small. I have rejected pull requests because they were too big. And I have another quote here that's going to try to lead you in the direction of let's make pull requests small from Swizz. He's a US-based blogger. He's not from the BC world, but he talks a lot about the engineering mindset. So I really like reading his things. And what he wrote in a recent post was, but when code's finished, it's too late for deep feedback. Any pushback breeds resentment. What do you mean you don't like my beautiful baby? Right? Where does that come from? It comes from the fact that the developer just spent 3 weeks developing, and now they're afraid to open a pull request because there's going to be a ton of comments there, and we're going to have to fix it for the next 2 weeks. How do we fix that? By not developing for 3 weeks. By opening a pull request after 2 to 3 days. If you open a pull request after 2 to 3 days, I guarantee you that you won't get comments that you will have to work on for the next 2 weeks. Yeah, another thing that Swizz said was, you know what's worse than a meeting? Building the wrong thing for a week. So let's try to build the wrong thing for 2 to 3 days at best. Personally, for me, the ideal work span is up to 3 days. Up to 5, it's okay. But 2 weeks, I think 2 weeks is no longer okay. Because after 2 weeks, if you've been developing for 2 weeks, the pull request is going to be big. But the second problem is that estimates no longer work at the 2-week period. Because if a developer says this is going to take 2 weeks, it's just as likely to take 1 week as it is to take 3 weeks. But if a developer says this is going to take 2 to 3 days, well, then it's most likely going to take 2 to 3 days. I know that, well, to get to smaller pull requests, we need to have small work items. So if we put more effort into breaking the user stories down, breaking the use cases down, it's going to be much easier for us to actually have smaller pull requests. But I also understand that just because I want us to have small work items doesn't mean that on Monday morning you can work with smaller work items. I was working for that same partner I mentioned earlier, the one that wanted to have exit statements capitalized, and they simply dropped a 70-page PDF on my table saying, go develop this. But instead of me developing in my little cave for the next month, I agreed with the developers and the reviewers that I'm going to create intermediate pull requests. I didn't make a pull request to the main branch. I made a pull request to the feature branch every 2 to 3 days, and that allowed the reviewers to actually review code. They were able to follow along how the feature is evolving, and I was able to get feedback that I can work on. I didn't wait till the pull request grew to 100 files, and then trying to change something is kind of difficult. Now, I know that intermediate pull requests, You might go for it, you might not. But I would say the very least thing we should do with code review is plan time for it. Because let's say we do sprints, right? At the beginning of the sprint planning, we're really good at estimating the time needed for development. And we're really good at estimating time for testing. But code review? Nah, you'll find the 10, 15 minutes and you're gonna review it. Yeah, you'll figure it out. But now imagine this situation. It's Thursday afternoon. I'm a bit behind on my tasks. But I think I'll figure it out, I can make it, even though tomorrow's the end of the sprint. And now somebody opens a pull request with 70 files changed. How much of a good job am I going to do there as a reviewer? I'll let this graph answer for me. The bigger the pull request, the quicker I'm just gonna scroll through it, right? I won't actually be paying attention to the details, and that's how we're gonna end up with bugs in the production. I have another slide that emphasizes that we should keep pull requests small. Ask an engineer to review 15 lines of code, they'll find plenty of issues. Ask them to review 1,000 lines, looks good to me. So yeah, if there's one thing I want you to take away from this session today is, let's keep pull requests small. Okay, now we're going to talk about the roles and the reviewers. Let me ask you this. Who has never reviewed code before? No one. One person. Everyone else has been a reviewer before. So let's take a look at how can we be better when we have to review code. And the first point for me is that as code reviewers, we need to be timely. Because when does code review come? It comes at the end of the phase, right? Somebody has been developing for 3 weeks, and now they're waiting on our input before they can merge the code, close the ticket, and move on. So they're essentially blocked by me, by my input. And I think we should actually prioritize code review higher than my own development tasks. The way I do this is that I have like 2 mental blockers, one in the morning after I had my coffee, and one in the afternoon after lunch, where I go through open pull requests. And what this gives to the developers is predictability. They know exactly when they can expect the next batch of input, right? So if I left a bunch of comments, they resolve them, and they know, oh, okay, in the afternoon, it's either gonna be more comments or a success, and we can merge things through. So as reviewers, let's be timely when it comes to code review. And for the other 2 points, reviewing the changes, not just the syntax, and sticking to scope, I have a couple of examples ready for that. So let's jump back into Azure DevOps. And let's go to one of the pull requests. We're gonna start with the add location loop to sync inventory. Now, I mentioned this during policies. If we require work items to be attached, well, then they have to be attached. And that means, how can I focus on the change, not just the syntax? By understanding what the developer tried to solve, what the problem was. And if I have a work item attached, I can simply navigate to it. Now, it doesn't really matter what it says up here. But what matters is that I, as a code reviewer, I can understand what the problem was. And once I understand the ticket, that's when I can go back to the pull request and start reviewing the code. And now I'll be able to review the change, not just the syntax. A quick side note, if you're using Azure DevOps, there's an extension that you really should install to make life of code reviewers easier. It has a really long name. AL Language Syntax Highlights for Microsoft Dynamics 365 Business Central by Microsoft. It's a free extension, and I'll show you in a moment what it brings. But it's really useful for code review. Because if you don't have this extension installed, all of your code is gonna look like this. Boring, plain white. Ugh. But if you do install the extension, once you navigate to individual files, you can see that the reserved keywords are now blue, and hard-coded strings are now this orangey browny color. Hard-coded integers are green, and the rest is still white. But even this helps so much with readability of code. It makes it much easier for us to review code like that. Okay, so we already talked about the first point, where we want to review the change, not just the syntax. Now, the second one I was making is, let's stick to scope. And what I mean by that is, we saw in the work item that they were working on something related to sync inventory. We can also see that from the name of the pull request over here. Now, does that mean I cannot leave a comment saying, hey, there's a typo in order sync? I think we can. Typos are fine, because they're a quick fix. But what we shouldn't do as code reviewers is go completely outside to something like company sync functionality and leave a comment saying, yeah, could you while you're at it, could you refactor this so that it only syncs for European companies? Yeah, that's a bit out of scope. That's a completely separate work item. And now, it's easy to point that out here because the pull request is small and there's only one work item attached to it. But when we have those pull requests where there's 3 user stories attached to it and maybe 2 bug tickets as well, that's when the lines get blurry and we don't really know what's in scope and what isn't. And that's how we end up with those pull requests that just seem to grow and grow and grow and grow, and we never seem to merge them in. So as code reviewers, let's be timely. Let's focus on the changes, not just the names of procedures and variables, and let's stick to the scope. Okay. Now this next slide for the reviewers is about coding guidelines. I've recently learned that not a lot of organizations have their own coding guidelines documented. So let me ask you, who has their coding guidelines documented? Oh, a bit more than I was expecting. Still, not all of you. So I'll try to use this slide to motivate the rest of you why it's a good idea to have the guidelines documented. Even we didn't have them 2 years or so ago. But then we had a couple of scenarios happen that made them quite invaluable to us. The first one was different reviewers, different rules. Let me tell you what happened, and it was frustrating. I open a pull request, and a reviewer joins in. And they go through my code, and they see, I see you're using validate in a lot of your procedure names. I don't think you should use validate because, validate has a lot of meaning in BC and AL. We validate fields. I think you should be using verify instead. Yeah, okay, fair point, why not? I change the code, I make the update, we merge the code in, everything's fine. A week later, I open a new pull request. A different code reviewer joins in. They go through my code, and they go, I see you're using verify in a lot of your procedure names. I think you should be using validate, because validate has a lot of meaning in BC and AL. We validate all of the fields. Oh, that's so frustrating when you have 2 reviewers requesting 2 completely opposing things. And that's where coding guidelines really shine. Because if you have your guidelines documented, it doesn't matter verify or validate. What we agree on, once we put it in this document, well, the guidelines become the ultimate arbiter in disagreements. It doesn't matter what the reviewer thinks. It doesn't matter what the developer thinks. If it's in the guidelines, that's how we write code at the end of the day. And I have another example that happened to me a couple of months ago. Let me jump into a different pull request for that. Let me find one. Pull requests. This one. Let me just jump into the changes that I want to show you. Okay. So the developer had to do a small thing. Just add a gatekeeper to the in-queue job entry function. Nothing big. But when I was going over this, I saw that in-queue job entry actually has quite a lot of parameters. So I left a comment, hey, I think we should break those parameters down because horizontal scrolling is not really something we would like to do. And I was already getting pushback from the developer. Why would I break procedures? Microsoft never breaks their procedures. Why should we? Well, Microsoft doesn't have all the best guidelines in the way they write code, but still, over time, I was able to convince him that horizontal scrolling is not good, and they said, yeah, okay, I'll fix it. This is how they fixed it. They took half of the parameters and moved it to a new line. And to me, that's even more confusing, actually, because now I don't know what is the fourth parameter over here. I have to count everything, and I was like, yeah, well, I want you to change it again. But instead of us going back and forward on how we should break parameters, if we should break parameters, instead, we added a section to our guidelines. You don't have to read this block of text. Essentially, what it's saying is, if a line goes over 120 characters, we're going to break procedures. If we break definitions, we break them like this. If we break invocations, we break them like that. And now, again, doesn't matter what I think as a reviewer, doesn't matter what the developer thinks. This is how we break procedures. Now, hopefully, come on. My clicker stopped. I have to click in the presentation, I think. Yeah. So hopefully, you got a bit inspired that you would like to have your own guidelines documented as well. And the question is, where do you start? Well, I would say check out alguidelines.dev. Now, I'm going to show you how alguidelines.dev look like. But this is a community initiative where people from the community have contributed their own guidelines and best practices up there. And you can go to this website, you can see those guidelines. You don't have to obey all of them. You can just choose whatever works for you and let that be the baseline for your guidelines. And then document whatever else you're however you write code in your organizations, and add it, and let that be your document. And if you document some of the guidelines that you have, that you think, hey, I think more of the community could benefit from a guideline like that, I would really invite you to contribute back to this initiative. Now, let's check it out, just how it looks. When you click the link, this is where you come to. Guidelines and patterns for development for Microsoft Dynamics 365 Business Central. So I don't want to go through too many details here, but once you go to the docs, this is where you can find and read about design patterns, right? What is a facade? Or what is a generic method? I know Waldo loves the generic method. I didn't even know what a generic method is. But here I could go and read about when do you use a generic method? Why do you use a generic method? What kind of problems does it solve? So this is the design patterns section. You also have best practices over here. These are, like I said, we don't need all of them. Just choose the ones that you are already using. For example, there's one that I actually disagree with. There's the unnecessary else. Else should not be used when the last action in the then part is an exit, break, skip, quit, error. This is supposed to be bad code, and this is supposed to be good code. My personal opinion is that the bad code is actually clearer because it indicates that there's only two possible outcomes here. While the good code, but again, you know, maybe you think differently. Choose the best practices that you would like to use and let that be the basis of your coding guidelines. The last page that I want to show you from the guidelines is the contribution page. Like I said, if you do go and document things in your own organizations that you think are applicable to a wider audience, really, go here, open a pull request, everybody's going to love it, and I think it's only good for the whole community if we write the same code, more or less. I have two more examples about guidelines. First one, a couple of months ago, I was tasked with reviewing a code base of a product that we adopted, and I was supposed to say how much tech debt do we have. This was the kind of code that I found there. Now, the first problem is I don't speak Dutch. I have no clue what's happening here. And I hope that at this point we're all writing code in English now. But what I was trying to showcase here is we all have coding guidelines. We don't just write whatever we want to write. Because otherwise we end up with procedures like these where we have a prefix on the parameter f, which is what, for parameter? I don't know. So yeah, we all have guidelines, so there is something to document. And another thing that we will have to do with guidelines in a couple of months is discuss what are we going to do with this. We all saw this during the keynote when Vincent showed it. But, well, I love the idea of this. Not only because you can pass now the instance of a code unit, but also you can have your global variables prefixed with this dot global variable or this dot local procedure. I like the idea of prefixing global variable. I'm not sure I like the idea of using it on local procedures. So internally, we're just going to agree on how do we use this. We're going to add it to the guidelines. And that's how we're all going to use this. It's not going to be, I use it this way, you use it that way. We agree on how we're going to use this new functionality. OK. And now we have this last part of reviewing the reviewer, which is clear communication is key. We talked about before of one type of fear. Like, why do I not want to open a pull request? Well, because I'm afraid that there's going to be a bunch of comments that I will have to solve now for the next 2 weeks. Yeah, that's one reason. Another reason why I wouldn't want to open a pull request is because there's that one developer who's going to join in, and he's just going to complain, oh, I would do this differently, and this is poorly named, and this is poorly named. Yeah, nobody likes to open a pull request and then get a lot of complaints on it. So I think that clear communication really is key. And the way I approach this is that I look for 5 types of code, and I change the way I communicate based on these 5 types of code. I look for good code, code that solves the problem, code that's readable, code that's maintainable. Good code doesn't really need a comment. I look for could be better code. Code that still solves the problem, but could be better, maybe better structured, maybe better named. This code usually gets a comment. There's bad code. Bad code never gets merged in. An example of bad code is, let's say, something that's an obvious performance hit, or something that could potentially lead to data loss. That's the last thing we want, for our applications to cause data loss. Code is temporary, data is forever. There's also meh code. That's the kind of code where I would do things differently, but am I gonna block a pull request because of that? I won't. And with meh code, is where I use the power of init, and I'll talk about that a little bit later when I show you the examples of these types of code. Now, the last one that I look for is amazing code. Now, amazing code, of course, comes from the developers who develop the algorithms that I could never think of. Yeah, that is amazing code. But amazing code can also come from a junior that just takes the next step, that delivers more than I sort of expect of them. For example, let's say I task a junior with creating a field in one table, creating a field in another table, and then they need to write a line of code in a code unit somewhere to transfer the field from one table to the other. That would be good code. But if the junior also sees that this procedure where they had to add a line of code is actually getting kind of big, so they split it down to different procedures, they documented it, well, that's amazing code to me. Because maybe I would expect this out of a senior developer. I did not expect it from a junior. And this is actually the area where I want to improve myself more. That I don't only tear the pull requests apart, but that I also try to look for the good parts. You know, this is good, thank you. I like the contribution that you made. And now I have a couple of examples of just how these types of code look like. So let's jump into the next pull request. Okay, let's see. Now we're going into the add address 3. Let me just filter down the changes. There we go. I'll make it full screen, close the comment. Okay, so this was the example I was talking about. Somebody needs to add a field to the customer table, and they need to add a field to the custom customer address table. And then they need to add a line of code in a code unit somewhere that transfers the address 3 from one table to the other. And this would be good code. Solves the problem, no problem here. So let's move on. The next request that the developer had was to add some validation logic. So if address 3 is the same as address 2, then clear address 3 and clear it in the connected table as well, because we don't want to have duplicate data in two fields. Now, this is actually could be better code because it does solve the problem, but the name, process address, is a bit too vague. We know exactly what this procedure does. So, could be better code gets a comment, and this is where I try to explain, yeah, hey, what you did was okay, but I think you could rename it to a clearer name, not just because of you when you get back to this code, but for anyone trying to finding this process address function and not really understanding what does it process. So this would be an example of could be better code. Now the next example I have is of amazing code. Right? Remember from before, this was the line that they wrote. So moving address 3 from one table to the other table. However, the developer also noticed that this create customer from template procedure is kind of big. It's doing a lot of things because it creates a customer from template, but then it also assigns a bunch of fields to the customer record, and down here it's also modifying the customer address table. So they realized this could be better if I extract this to a separate code unit, to a separate procedure. And like I said, to me, that's amazing code. It's a bit difficult to be enthusiastic about this example that I fabricated just for today, but I think you get the point, right? We don't want to only look for the bad parts of pull requests. We should also sometimes look for what's good, what was done well. Finally, I have an example of meh code. For that, I'm going to switch into the file, and we have to switch to the modified content view. Okay, this is how the code looks after everything was extracted. Good, I like it, it's nice. But in reality, I would want to have a line break under this modify, so it's a bit clearer what kind of changes are done on the customer record and what are other changes, right? But will I ever block a pull request for something like that? I won't. But these are the types of comments that I prefix with nit. This is the power of nit that I was talking about. Nit stands for nitpicking, and what it brings is it gives all of the power to the developer. The developer can decide, do I care about this comment? Do I want to add a line or not? And they can decide, yes, I will add a line, or no, I won't, and they just mark it as won't fix it, right? And not only does it give all the power to the developer, it also gives me as a reviewer a lot of power, because a lot of the times I have been in a situation where I already leave like 20 comments, and then I think to myself, do I really want to comment on something as meaningless as this? I don't know. Well, with Neat, I can, because it's up to them. They will decide, do they want to do something with this, or do they not? And at the same time, this Neat is also really useful for juniors, because with juniors, I would like to tell them more often that, hey, what you did was okay, here's how I would have done it. Not because anything's wrong with your approach, just that you're exposed to, hey, there's an alternative way. And that's when I prefix it with Neat, and they decide, do they care about the comment, or do they not? So, really, use the power of Neat. It's useful both for the reviewers and the reviewees. So clear communication, I think, is the most important part. Because if we clearly communicate our intentions, we build trust with the developers. The developers become less defensive, and they will be more willing to receive feedback. Okay. Now we come to the last section, which is reviewing the reviewee. So when my code is being reviewed. And again, here I could ask you, who has never had their code reviewed? Yeah, we all had our own code reviewed. So what can we do to be better in this part? And the first point is, let's focus on design before code. Because we talked about a situation where I'm developing for 3 weeks and I get a bunch of comments on my pull request. I can avoid that if I bring all of the reviewers and the developers with me to the design phase. And if we agree at the beginning, how are we going to implement this feature? How are we going to solve that problem? Well, then there's not going to be any surprises 3 weeks later once we do open up a pull request. But I know that's kind of difficult because thinking before coding, coding before thinking, that's what we like. We like to just jump into the feature, and I'm guilty of that myself, right? I like to solve the problem as I kind of work through it, but there's just so many benefits if we do that ahead of time that we should. The next 2 points are, let's review ourselves first, and let's be proactive in clarifying unclear parts. And for that, I again have a couple of examples ready. So let's jump into our pull request. This time, which one I'm going for? This one. When you open a new pull request, you can first open it in draft mode. And in draft mode, there's no reviewers, and there's no pipelines. It's just you and your changes. And you can use this opportunity to go through the code from the same way as the reviewers will have to go through it. Right? You view it from a different perspective, because we're used to looking at our code in VS Code because that's where we developed it, but this is how the reviewers are going to see it. So it's beneficial if we first go through our pull request and we see, oh, wait a minute. I actually didn't want to comment this out. This was just for testing purposes, right? I can catch my own mistakes before somebody else has to, because I just get a view from a different perspective by reviewing it through Azure DevOps. Now, the second point was, let's clarify unclear parts ahead of time. With this, I'm primarily targeting places where we already know that maybe somebody's going to have questions in this part of the pull request. Well, why not leave an answer ahead of time? For example, our amazing code over here, if I see this kind of pull request from a junior where a bunch of lines are deleted, red flags are going to go up. What's happening over here, right? But if the developer leaves a comment ahead of time that, hey, don't worry, I just moved this to a separate procedure to make it clear, to make it more readable, then the flags go down again, and I'll be fine. I'll understand that, yeah, we didn't just delete a bunch of code because tests were failing. We actually wanted to refactor and improve code. So as reviewees, let's review ourselves first, and let's be proactive in clarifying unclear parts. And then there's one last point: be open to feedback. When I was preparing for this session, I tried to pay attention internally on our pull requests if I'll ever get an example that I can use for be open to feedback. And I did. A couple of months ago, there were these two comments. I need to push this pull request fast. I don't have time to argue. And I get where the developer was coming from. They had a deadline for tomorrow. They needed to merge things in. But the only response that this kind of comment can get is, okay, let's hop on a call, let's go through it together, let me help you merge this faster. But urgency and deadlines cannot be an excuse for us to merge bad code in, because we're just gonna end up in a situation where we have glitter bomb-worthy code in our production. So the kind of code review requests that I don't like are these ones. Let's review the code, not only approve and rubber stamp. Okay, now we're coming to the age of AI, to the last slides about GitHub Copilot. Has anyone used GitHub Copilot? And let me be clear, I'm not talking about the wonders of GitHub Copilot in Visual Studio Code. That one I love. GitHub Copilot in GitHub, so the enterprise one. No one. I know why. I'll show you why we're not using it. But I was hoping that somebody's going to share their experience, because I haven't used it either. But that Enterprise Copilot, what it's supposed to bring for the code review is this. It's going to help us write pull request descriptions. We didn't even talk about pull request descriptions today, because not that they're not important, they have their place, but they're just not that important. And the reason why I cannot really endorse the enterprise version of Copilot is the price. I love GitHub Copilot in Visual Studio Code. I can argue for every, let's say, experienced developer that they should have a license to the GitHub Copilot in Visual Studio Code. But the enterprise one, it costs twice as much. And not only does it cost twice as much, you need to have the GitHub Enterprise license. So instead of me arguing for this developer needs to have a license for $25, I would need to argue for $60 so our pull request descriptions can be generated automatically. Now, the Enterprise Copilot has additional features, but I just wanted to point out that for code review, we didn't get much yet. But I did when I was preparing for this session, I was on a lookout if there are other AI tools and what do they bring in the sphere of code review and how are they going to help. Again, I'm not trying to endorse any products because I've only kind of played around with them. But this is just to show you what maybe one day Copilot will do for us. I have something called CodeRabbit. Before I show you what's happening here, this is essentially a pull request that adds this code unit to the code base. Just to briefly explain what's happening here. A couple of months ago, I was trying to build a toolkit that would help us evaluate and test AI features. So it's a toolkit that sends a lot of requests to OpenAI in parallel. So I can send 100 requests to OpenAI, get 100 responses, and then see are those responses okay or not, right? And what this specific code unit here was doing, when all of those 100 test cases went through, it calculated the total number of test runs, right? All of the 100 runs that I've executed. And then it's going to calculate the successful ones, and it's going to calculate the pass rate. The rest we don't really have to care too much about. But that's essentially the calculation that's happening here. And when I created this pull request, this CodeRabbit tool, Again, of course, it creates the description for us. Okay, fine. But it also actually starts performing the code review. And you get a comment, it understands that, well, you're doing some calculations here. You're trying to divide with total runs that can be 0. So consider handling the case where total runs is 0. Not really groundbreaking stuff, but what I'm trying to highlight here is right now, co-pilots in GitHub, they don't do much for code review, but I think in a few months, in a few iterations, we might actually get co-pilots that will help us perform the code review because they will catch things like this for us. Okay. So now we come to the last part, which is a couple of key takeaways that I want you to remember as you exit this room. And the first one is just do the code review. Policies don't matter. Pipelines don't matter. Co-pilots don't matter if we don't do the code review. So let's start there. Let's just do the code review. The next one is let's focus on design before code. Right? We talked about it. Let's take our development team, let's bring it with us to the beginning, let's agree how we're going to solve the feature, how we're going to build it out, because otherwise we're going in the wrong direction. Right? So let's focus on design before code so that we don't go in the wrong direction. This third point, I think I was making it quite a lot today. Let's keep pull requests small. The next one is about adopting process improvements to make reviews faster. Once we're doing code review, that's when we should think about pipelines, and that's when we should think about linters, because there's all sorts of questions that I, as a code reviewer, don't have to think about. I shouldn't think about those questions. Let that be the work of the automation tools. And then finally, let's clearly communicate our intentions. Because if we clearly communicate what we want from the developer, we build the trust, we lower the defensiveness, and the developer is going to be more willing to receive the feedback. So those are the 5 key takeaways for today. And I want to leave you with one final quote that a friend of mine from UK said after I did this session in Birmingham at the beginning of the year. What he said was, we need to understand that pull requests aren't an obstacle that we need to overcome, but a tool to collectively have better code. And with that, we come to the last part, which is, this was all from my side, and now if you have any questions, I have t-shirts and I have the catch boxes. So, okay.
So thanks for the presentation. When we see the things we do with pull requests, I think it's mostly in the context of distributed teams and asynchronous communication, something like that. So I was wondering what your thoughts are about when we have a setting where all the developers are in the same room, they can talk to each other, something like that. If we could skip pull requests and do pair programming instead, because they can talk to each other about the issues in the code because they are looking at the same screen and make the fixes right away.
Yeah, so with pair programming, the thing is, I've never done pair programming, so I don't really have experience with it, but I do agree that if 2 people are building the code together, it's already a code review at the same time. So I could, oh, here's the t-shirt. Yeah, I mean, I would agree with the idea that code review is not as important if we're already doing code review while we're building everything out. Oh, sorry, there was a question behind you as well.
Yeah, so I have a question about the build validation.
Yes.
Does it make sense also to run all of the automated tests every pull request, and I don't know, you update pull request, other merging to master, so every time run
Yes.
automated tests? And what if they run like, I don't know, an hour?
Then that's the problem you need to solve. I know we had this situation where our tests were running for 4 hours, and then it makes, I won't say it makes no sense, but it's really difficult to argue, run all of the tests on each pull request. But we fixed the tests, and once we got them to 1 hour, that was acceptable enough for us, that we now run tests on every pull request, on every change, because no pull request should be able to break something. We want to catch it immediately, right? So yeah, we run tests on every pull request.
Thanks.
Here's the T-shirt, and you get the mic.
Okay, so I have mostly a couple comments.
Yeah.
The first one, I didn't raise my hand before because I am actually right now implementing them. I am using status checks at GitHub because with GitHub Actions, they actually end up being status checks. My main developers asked me to check that some branches don't end up being merged to the main, for example. So pull requests from certain branches get rejected automatically, and that's a status check.
Okay.
In that case.
Thank you.
And the other comment was about the extension you showed that highlights the syntax for AL.
Yeah.
Do you know if you can change the colors on that? Because I noticed the comments are still green, but obviously if you remove the lines, you have a red background. I have a lot of colorblind developers, so that's really a big issue.
I don't know, and I think we need to ask Microsoft. Can we do that? I never played with it. Okay. Yeah, but thank you. More?
Thank you. My question is, we just recently started with pull request reviews.
Yeah.
We are very late on that. And I'm afraid the developers will not be too happy to have the pull request declined at first. And do you have any suggestions how to improve acceptability on that?
One thing I would say is we never really reject a pull request in our internal teams, all of us, right? If a product owner decided that a feature needs to go in, then a feature will need to go in. So we don't really reject a pull request. We simply wait for the input to be kind of resolved, right? But I think what you're asking is not about rejecting a pull request, but how to tell people, hey, you might have to do more work.
Right.
It is going to be a people issue in the end. So the best you can do is just have some people who are eager to do this and make it a slow change. I know it's always difficult to introduce a new process. So I think this is more of a change management question, and I don't really have an answer for that. For us, it was always easy to convince one additional person compared to trying to convince a full team of people of, now you need to do this way, right? It's much easier if the team already agrees we want to do it in a better way. So, yeah, I don't really have any good suggestions for.
Okay, thank you anyway.
Yeah.
We'll start with a few projects and see how it goes.
By some proactive person inside your team. And then evangelize the others.
That's for example, not with pull requests, but we did that with automated testing. In a non-BC related department, they were pushing back, we don't want to do automated testing. How did we get them to do automated testing? We got an experienced person in who already did tests and knew the value of tests. And slowly they convinced one additional person and one additional person. And in 6 months, the whole team was doing automated tests because slowly they understood where the value is and that there's not that much complexity to it. So I would assume that the same could work with pull requests.
Thank you.
Yeah.
Yes, thank you, Tine. Great presentation. In practice, how much time we spend to this section?
To perform the code review?
Yes.
When it's big pull requests, it's a lot of time. On that German project, I was spending 2 hours easily on a pull request, and that was just one iteration. It had to go through many iterations because there was so much code. When you come with smaller pull requests, when it actually is 2 to 3 days worth of work, 15 minutes is completely fine for me. Because it's not so many changes that I need to keep in my head. So with smaller pull requests, 10, 15. With big ones, we're talking hours.
Okay, thank you.
Anyone else? Yeah.
So what about if you have like typo mistakes and so on, you comment on that pull request, or you fix it and let the developer know?
There's two things. If it's a really simple typo, I think maybe I can show that. There's the suggestions directly in Azure DevOps, right? You can try to leave a comment, and there's I won't find it now. I think I need to go here maybe. Suggest. Oh, insert a suggestion. Here I could already fix a typo and immediately accept it and commit it, so that the developer doesn't really have to go through updating it. But normally I would comment on a typo as well. Right. I would do it with Neat, and they can then see, yeah, I'm gonna update something else anyway, right? It's up to them. It's their power of decision.
Okay, thank you.
Here. And then there's behind you two more.
Okay, so you said that we have to keep the pull request simple, small, to get the easy review. So what's the algorithm to split bit functionality that makes work from a couple weeks or something like that, and have to manage? I know that we can prepare how to indirect feature branch, we can make the pull request, but sometimes you can't split, because now
we had those where a user story is either just too big or we don't want to invest time into splitting it up.
Yeah.
We did intermediate pull request. Where's the limit? It was up to the developer. The developer decided, okay, I think these are the changes that a reviewer can handle. You know, that can be 2 days. It can be 1 week if it wasn't that many changes, and that was a pull request. So there's no hard limit on how we break a huge
so
feature down.
It comes down to the planning.
It's more just when the developer feels that that's enough, let's make a pull request. But you need to have proactive developers for that.
Okay, thank you.
So how is your whole process? The developer makes the pull request in draft mode, then looks over it, and then publish the pull request.
Yes.
Then you don't reject it, so you only make comments?
No.
Okay, so the word reject, you don't mean reject.
Yeah.
Okay, so you reject it, and when the process of over-development should be 3 days and perhaps 2 commits, then it stays in published mode, or is it the developer that sets it then in draft mode again back?
No. So once draft mode is just that small period for the developer to go through it, and then it's published. Once it's published, it's published. And what I meant with the rejects, right? We have all of these different statuses. Wait for author and reject for our internal teams are exactly the same, because we're never going to reject functionality, because that's the decision of the product owner, not me as a code reviewer.
But then you have a published pull request that is there for maybe 1 week. And the developer's not working on it.
No. So the thing is, with small pull requests, and when I review code twice per day, the pull request is open for 1 day. And then it's merged.
When the developer has time for it. Maybe it's working after this for another customer, so this pull request doesn't care him about.
Yeah.
So this is the
we are coming more from the product-oriented development, and there I see what you're aiming at. If you have different projects, then here I do the work and I don't have time to return to this pull request until a week later. Yeah, that's more of an issue.
So I think we have the solution that the developer himself approves the pull request, but the number of pull request approvers is added by one. So there are at least 2 pull request approvers.
Yeah.
And when the week's over and the developer says, okay, I'm fine with it, then he again approve it. So that when you look at it, you see, it's approved, so he's fine with it, and okay.
No, yeah, we don't do that. For me, it's more like when the developer does their changes, they push them up, my votes get reset, and that's my signal that I need to now go through it again. So until they're done with their changes, they just don't push things up, and that means the pull request is going to stay in the wait for author state.
Okay.
Yeah.
Thank you. Thank you for the session. It was very interesting. I wonder, how do you decide who exactly does this specific pull request? As I understood, you have a team of people, but who will do it?
Yeah.
If nobody have time at this moment.
We usually have development, like on a project, we have a leading developer. That's always kind of the main go-to person. It's their main responsibility. Now, when I was talking about knowledge transfer and that I would like to include more junior people, I don't really have a way for that just yet. But I would still have somebody who has responsibility for a pull request, and everyone else is being rotated. You know, or they can even all be tagged. I'm not sure. I don't have a clear way of how to rotate people who should be rotated. I don't know how to put it.
In our team, we have a weekly change who approves the requests when nobody has time, and its seniority is more or less the same, so works for us.
Good, but what we were struggling with is, what if you don't have enough experienced people on a project to rotate? And but yeah, no, that's a good point.
You mentioned that stick to scope is very important. I'm doing code review very often, and yeah, we have some very motivated developers that they add new procedures and see a typo, one procedure above or below, and then I fix this while I see it. And my problem sometimes, after they fix a typo in not related code, I see an error or something else, and normally I at least add a comment, and then we need to decide. But how would you deal with this situation that they?
You could also just say that you're stricter with sticking to scope and open a separate pull request, right? For all of those smaller things which are causing to bigger issues. Because like I said, typos to me are okay, but I can also see that a typo can be a rename, which can break other things in other parts. So it's, yeah, okay, it's a slippery slope. Maybe I should go back to just say, no, stick to scope. Don't go outside of scope, and out of scope should just be a separate pull request.
Yeah.
Anyone else? There's one, and yeah. We have 2 minutes left. Oh, I didn't even see you there.
Yeah. So if you have to think before you develop, do you have to think before you do the code review? Because if you would not rethink the solution, you could not judge in correct way. I mean, should you think about the solution before the code review?
My take is yes. I know that's not always possible, but whenever you can have the context of the problem, you should. But especially when you have multiple projects and you want to pull a reviewer from a different project, they won't understand this project. So it is going to happen that we don't always have the context to review the change, and sometimes we do just review the syntax. But my take is we should always know what the ticket is about. Okay, last question.
Have you ever tried to not include translations directly in feature branches and handle them in different process, and you found it better to pipeline validate it?
So our original approach was just merge features in, and then before the release we're going to do translations. But that meant people didn't have any context of what this word is supposed to be, because you just get that huge translation file, and now you have to translate individual words instead of like features with meaning, right? That's when we moved to the pull request needs to be fully translated, because then when you see a certain action name, you know exactly what this action name refers to if it has a more generic name. So that's why this was the better solution for us. I'm not sure if that
Yeah, I'm aiming more towards not handling translations directly in XLF files, but making it more friendly.
Oh, okay.
For consultants to do.
So we never edited them directly in the file. We had PoEdit, the tool that was more friendly for actually translating stuff. But yeah, the second benefit that we got from fully translating everything on a pull request basis is we didn't have any merge conflicts on the translation files anymore, because each pull request introduced new strings which were also fully translated, and they were never again modified by someone else that a different pull request would clash with the translations. Yeah. Okay. That's all the time we had for today. So thank you.